Hello, everyone. Welcome to the presentation of our science policy brief for the UN SDG STI Forum 2023. Our brief, Concrete Carbon Dioxide and Catalysis, aims to merge industry and research goals to present a unified approach towards sustainable development. Here, we provide an overview of carbon dioxide from concrete, research underway towards net zero emissions, and finally, what policies and actions may help us accelerate sustainable action.
So, cement, the main component of concrete, is responsible for approximately 8% of global carbon dioxide emissions. So, a question comes to mind, why is the manufacturing of cement so carbon intensive? There are two reasons. One reason is that during cement production, limestone is heated to very high temperature in furnaces, which releases carbon dioxide from the limestone. Another reason is that furnaces used in cement production must run at very high temperatures, that is around 1500 degrees centigrade, and this requires a lot of energy, often from fossil fuels, which also contributes to the carbon footprint of cement production. Overall, it takes around 0.9 kg of carbon dioxide to produce 1 kg of cement, and given the enormous amounts of cement produced annually, this quickly adds up. There are several approaches that can be taken to reduce the carbon dioxide output during the production of cement. At production stage, we can use waste-derived fuels, solar-powered calciners, and new types of cement such as limestone calcined clay cement LC3. We can also capture carbon dioxide for storage or utility through CCUS technologies. Collectively, these approaches would help in reducing the carbon footprint during the cement production. Similarly, at consumer stage, alternative cements such as LC3 or geopolymer cement can be used. Supplementary cementitious materials can also be used. The concrete design can be optimized with innovative technologies such as 3D concrete printing, requirement-based or sufficiency-based approach can also be adopted. Also, the use of nano-reinforcement can be opted for achieving a desired strength of the concrete instead of using high amount of cement. Additionally, at construction stage, workflows can be simulated with automated techniques such as building information modeling and prefabricated structural elements at quality control sites. In the circular economy of concrete, recycled aggregate concrete can be used and carbon dioxide can be sequestered or re-assimilated in natural environments. These solutions can help achieve a more sustainable construction industry.
However, we need to overcome some hurdles to ensure our research is adopted by the industry first. Significant R&D investment is required to enact these net zero measures at a large scale. Practical results would then incentivize clients to adopt greener practices, especially if these practices are marketed towards the clients. Simultaneously, building standards of the construction industry should be flexible and continuously updated to allow for net zero construction. Major stakeholders in the industry should work in tandem towards establishing a concrete culture. The governing authority should adapt stricter policies and regulations for concrete construction. Awareness campaigns will educate society in general and motivate net zero construction movements. Lastly, efficient and reusable design should be prioritized, along with retrofitting existing cement plants. This concludes our video presentation for the Science Policy Brief. We encourage you to read our articles and our cited sources for a more detailed overview. My name is Dr. Taimur Mazhar Sheikh, and I was joined by Dr. Habib Ahmed in this presentation. Thank you for giving us your time.